All around us, in power plants, refineries, factories, there are these devices holding back just immense, potentially catastrophic forces. And really, the only thing keeping them safe is a kind of invisible set of rules. Okay, let's dive into this and really uncover the system that keeps the modern world from, well, going boom.
So that really is the big question, right? If you're building something that's got to contain the pressure of, say, a locomotive boiler or a massive chemical reactor, you can't just guess. The stakes are just incredibly high. A single mistake could be absolutely disastrous. So how do you get it right every single time?
Well, the answer isn't a single person or some kind of magic formula. Nope, it's a carefully designed system, almost like a collaborative dance of checks and balances. And the choreography for that dance? Well, it's written down in the ASME code, specifically in a section called U-2. And that's exactly what we're going to break down today. So, to really get this, we're first going to meet the three key players who make it all work. We'll look at the specific roles of the user, the manufacturer, and of course, the inspector. Then we'll see how the system handles some really complex situations and what the ultimate symbol of its success actually looks like. I want you to think of this whole system as a three-legged stool. You've got the user, the manufacturer, and the inspector. Now, if any one of them fails in their duty, the whole thing just collapses. Each role is totally distinct, absolutely essential, and they all have to rely on each other to guarantee safety.
Everything, and I mean everything, starts with the user. This is the company or the person who actually needs the pressure vessel. They can't just walk up and say, "Hey, I need a tank." The code puts the responsibility squarely on them to be the architect to define the entire mission for this piece of equipment.
And they have to define everything. I'm talking about section U2A of the code. It says the user has to specify all the conditions the vessel is going to face. Not just normal, everyday operation, but what happens during startup, shutdown. What about potential emergencies or some kind of abnormal pressure spike? Does it need extra thickness for corrosion? All of this has to be spelled out right up front before a single piece of metal is even touched.
And for really complex projects, let's say you're building a super tall vessel that's got to withstand wind or seismic forces, the user has to provide this formal document. It's the official handoff, right? It's the blueprint of requirements that basically says, here is exactly what this vessel must be able to endure. It makes sure nothing gets lost in translation.
All right, so once that mission is clearly defined, we move on to our next player, the manufacturer. This is the master builder, the one who takes all the user's requirements and turns them into a real physical object. But their job is so much more than just building it.
And the code is incredibly clear about this. This quote right here, it puts the ultimate responsibility squarely on the manufacturer's shoulders. Even if the user made a mistake in their requirements, the manufacturer is still on the hook for building a vessel that complies with every single rule in the book. The buck really, truly stops with them.
So you can see this division of labor as absolutely crucial. The user defines the what and the why. What is this vessel for and why does it need to handle these specific conditions? Then the manufacturer is totally responsible for the how. How do we design it? How do we build it? And how do we make sure it follows the code to the absolute letter? And their to-do list is, it's pretty extensive. They have to produce all the design calculations that prove it's safe. They have to make sure their entire staff is qualified. And they even have to take full responsibility for any work done by subcontractors. It's their name and their reputation on that final report, the one that certifies everything is compliant. Okay, so we've got the architect and we've got the builder. But who's making sure the builder is actually following the plans and the building code? That brings us to our third and absolutely critical player, the authorized inspector. Think of them as the impartial referee in this whole process.
Now, the inspector isn't part of the user's company, and they're not part of the manufacturer's company. No way. They are an independent third party, and their only job, their entire focus, is to verify compliance. They don't design it, they don't build it, they just make sure that everyone who is designing and building it is playing by the rules.
And let me tell you, the code gives them some serious authority. They monitor the manufacturer's quality control system, they pore over the design calculations, and they conduct their own inspections. Literally nothing moves forward without their say-so. They hold the keys to that final, critical step, authorizing the official certification mark.
Okay, so a system with three distinct roles sounds great on paper, but what happens in the real world? Where things get a little messy. For example, what if the code doesn't have a specific rule for some new, innovative design? Well, the system actually has an answer for that.
See, the code totally anticipates this. Section U-2G gives 3 very clear paths forward. The manufacturer can use a specific appendix for guidance, they can conduct a physical proof test to literally demonstrate its safety, or they can use another recognized standard. But, and this is a big but, only with the inspector's final approval. This makes sure that even when you're in uncharted territory, safety and rigor are never compromised. And check this out. This table shows the system's flexibility for another really common scenario. Building a vessel so huge it has to be assembled out in the field. The code provides 3 options, and each one clearly defines who holds the final responsibility. So it doesn't matter if the original manufacturer finishes the job or if another certified company takes over. At the end of the day, there is always a single entity that signs that final report and takes full responsibility. No confusion, no finger pointing.
So, after the user defines the mission, the manufacturer builds with total integrity and the inspector verifies every single step. What's the end result? It all comes down to one incredibly powerful symbol. This is it, the ASME certification mark. You'll see this stamped right onto the nameplate of a pressure vessel. And yeah, it might look simple, but it represents the successful completion of this entire incredibly rigorous process. That one little stamp signifies that one cohesive system has worked perfectly. One team, the user, manufacturer, and inspector, all collaborating successfully. It means that dozens, maybe even hundreds of rules have been followed, checked, and verified, all culminating in that one mark of safety. Ultimately, this mark isn't just about a piece of equipment passing some test. It's a symbol of trust. It's the physical proof of a system of shared responsibility that was designed over 100 years ago, born from the ashes of deadly boiler explosions, and has been protecting lives ever since. And that kind of leaves us with a final thought, doesn't it? In a world filled with complex technologies, everything from AI to spacecraft, what can we learn from this century-old system of defined roles, shared responsibilities, and independent verification when it comes to managing today's high-stakes risks? Something to think about.